Now we come to an idea that many students find harder than distance traveled. Distance traveled was simple in one way. It only added the total length of the trajectory covered by the body. But physics often asks a different question. Not only, how much did the body move? But also, where did the body finish compared with where it started? That is a completely different question. Imagine that you start at your house, walk to a store 300 meters away, and then walk back home. Your distance traveled is large. 300 meters plus 300 meters equals 600 meters. But where did you finish? Back at home. Your final position is the same as your initial position. So your displacement is zero. This is the most important mental picture. Distance traveled remembers the whole trip. Displacement remembers only the start and the finish. If distance traveled is like the trace left behind by the body, then displacement is like one arrow. That arrow starts at the initial position of the body and ends at the final position of the body. It does not care whether the body moved straight, curved, in a circle, or back and forth. Displacement only asks, where did the body start, and where did it finish? So in physics we say, displacement is the change in position of a body. More precisely, displacement is a vector from the initial position to the final position. The arrow points from the start toward the finish. Here we meet a new word, vector. A vector does not describe only how much. It also describes which way. For example, saying 5 meters is not the same as saying 5 meters to the east. The first statement gives only a size. The second statement gives a size and a direction. For displacement, direction is necessary. If a person moves 5 meters to the right, that is not the same displacement as moving 5 meters to the left. The magnitude is the same. But the arrow points the other way. That is why displacement is a vector quantity. A displacement vector has a magnitude, the length of the arrow. It has a line of direction, the line along which we compare the start and the finish. And it has an orientation, or sense, the side toward which the arrow points. On a straight road, the line of direction can be along the road. The orientation can be to the right or to the left. On a map, the line of direction can be north-south. The orientation can be toward the north or toward the south. So it is not always enough to say, the displacement is 10 meters. To describe the full vector, we also need to know which way the final position is from the starting position. But sometimes we talk only about the magnitude of displacement. The magnitude of displacement is just the length of the displacement arrow, without direction. If you say, the magnitude of displacement is 10 meters, you only say how far the final position is from the initial position. If you say, the displacement is 10 meters to the east, you describe the whole displacement vector. This difference matters because some problems ask for displacement, and some problems ask only for the magnitude of displacement. The physical meaning is this. Displacement describes the change in position from start to finish, no matter which trajectory the body followed. That is why two bodies can have the same displacement even if they traveled along different trajectories. Imagine two people going from one city to another. One travels by bus along winding roads. The other flies by airplane along a different route. Their trajectories can be very different. Their distance traveled can be different. But if both started in the same city and ended in the same city, their displacement has the same start and the same finish. So the magnitude of displacement is the same. Displacement is a very forgetful idea. It forgets the whole history of the motion. It remembers only two things: the initial position and the final position. So when you see a motion problem, do not confuse the trajectory with the displacement. For distance traveled, follow the whole trajectory. For displacement, draw one arrow from the start to the finish. And if the body comes back to where it started, the displacement is zero, even when the distance traveled is large. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.